Hello everyone, welcome. Hello everyone, welcome to another tutorial on on the internet computer. My name is Samuel and I'm taking you through today's session. So basically, today's session is about learning how to create tokens on the internet blockchain and the different types of tokens that are there and different standards and everything you need to know about tokens. And so without wasting time, let's dive into the session. So yesterday we had actually talked on creating a simple project, and if I open up my code editor, you see that this is the last portion of code that we had written, and we were actually trying to experiment with uh, access based on principal addresses, and but it wasn't much of it wasn't much code. And so today basically we're going to talk about tokens, everything you need to know about tokens and how you can actually create your own token. So by the end of this video, you should be able to create your first 100 million token on the internet function blockchain. And so I'm excited for this session, and I hope you are. And without wasting time, we can jump into the video. So let me go to our main internet function website, and this is the home page. So we want to look for a section where we can get some information about tokens and writing coin tokens. And so now we'll click on views and then scroll down where it says DeFi. And you can see that we have the full menu overview, ICP tokens and CRC tokens, and I'll click on over. And so overview of ICP, they show you, let me see if this is not the total, you can select that. And so here we are showing you the overview of ICP tokens and DeFi in general, and then say legendary report transactions in a chain of block. One block difference says its current block on the blockchain that is immutable without any other previous block in the chain. ICP protocol utilizes two different types of chain ledgers. First ledger is ICP ledger, it's one export dynamic and the connection of the ICP ledger is running on the dynamic subnet. The second type of ledger the ICRC1 ledgers, and this one we both types for the showing and then businesses will be highlighted. And so they go ahead to show you talk more often about the ICP ledger and also the ICRC1 ledger. And basically ICRC1 is a token standard on the internet computer, just like how we have ERC20, which is a token standard on CVM. And so we have ICRC1, we have also ICRC2, and down below they show you how, the difference between the ICP ledger and the ICRC1 ledger. There's more, there's a couple more information about account and account management. So if you have some time, you can, access this doc and, read through, understand, a couple of things about tokens. And so today's session will be hands-on, and without wasting time, let's today we're going to create a simple token, and we'll walk you through the whole process of how you need to set up your project in order to be able to deploy your token. And so I will just the type of token that we're going to create follows the ICRC1 standard, but you can also create a token which follows the ICP token. And so I will click on ICRC1 token, and then I will click ICRC1 legislation. And so this page basically shows you how to uh, set up an ICRC1 ledger on your local machine. And as you can see, step one, make sure you have a recent version of the ICS feature. Second step, it shows you create a new DFX project with command F4 in, laser canister, and then you might get into that project, and then maybe you can in your favorite code editor. For now, we are using VS Code, and we already have our project set up, so we will skip this uh, step. So the third step is actually to determine the laser qualifications, and I'm going to show you uh, when these files are located on GitHub, the URL. So basically, to set up the laser file, you need two things. You need the .zip file, it's rather it's candid file, and it's working. And so the candid file actually defines the interface that can be accessed on that laser operation, and the interface, is a bunch of functions that you can call in that token canister. And the origin is actually that instructions, combined into the lower level language of working, and it allows you, to set up everything. So, all right, so here we are, they're showing us the area of the laser from GitHub, and so we have two options here. We can either, run this script, and it will download everything for us, or we can, use these URLs in our GitHub suggestion, and we don't need to download the laser file and the working file and all of that. And so we will continue to step 4, and step 4 says open the DSS notation and replace the existing content with the following. So I will just copy everything here. Rather, even if I don't copy everything, I can just copy this definition of the canister that I want. Since it is an ICP major canister, I will just copy its configurations, fill up my DSS registration on my machine, and come on here and paste it. Alright, so as you can see that now we have a new definition of canister, and it is showing me an error. So when you think that coming from, okay, so maybe you can delete this and put a comma here. Right, so the error goes away. So a couple of things about the ICP with the canister is complete custom, and the candy is posting the GitHub, which has this number in here. And if you go back to the guide, you see that this is a special number that determines the release, the current actual version of the release, and you need to replace it with the updated version of the release, or the current release version that is created. So I will click on release overview, and close up the dashboard. I will need to get access to the latest release and copy its ID. And as you can see, we wait for it to load. Okay, so taking some little time, and right here you will see that we have a release that was published on 1st April 2024 at around, I think, 3 minutes at 8 a.m. UTC, and the replica version is this, so we will have to click on that replica version, and then we should be able to copy it from it. So it's here. So this is the latest actually replica version, and it's recommended that you always use it when you're trying to install this layer. So I will come here and replace this with the latest replica version, and I'll click save and save. So we are done setting up the DFS JSON. So the next thing is to go back to our layout and see what they want us to do next. So after setting up, this is also There's also another option whereby you can actually download the legend of this file and also the legend of working file on your machine. And in this case, instead of pointing the candidate and logging to the GitHub URL, you just point them to the downloaded laser bit file and working file. But for us, we are going with a method on this step, and so we just have to ignore this. So the next thing they want us to start, our replica on our machine, and how to do that really well. So let me just do here, 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 then I'll just take this, and they say DFX is already running, which is okay. We want to be able to run the replica service and deploy our function. So we're on step 6, and uh, we have to create the required identities and export our initialization arguments. And yes, so first one, we want to create a new identity of Minter, then we switch to use that Minter identity, and then we export it for address. So I'll just copy this and select OK. So they say identity already exists, meaning that we already have that identity running or configured in my machine. So we just go the next step, which is to use that identity, and then we export its principal address in a variable called Minter. So if at all I do DFX identity one, you should see that we are using the Minter identity and it's working well. So we are done with that. The next thing is actually to define the name of our token and also the symbol of our token. So I will copy this and come to my terminal, my report from first press this here, and I will change the name of the token and also the symbol. Just put double T, copy everything, again cut and paste it here. So we configured the token name to be test token and also the token symbol to be TT. Alright, so we're done with that step. The next step is actually to set the default identity with which you want to deploy your laser with. And so here it is. I will just copy this. Most of the instructions are straightforward, and do that. So I switch using the default identity, then export its principal address in a variable called default. And this is the same identity that we're going to use to deploy our token, plays, and kind of stuff. And so back to the code. Alright, so we're on to the next step whereby we're saying we can, we need to define the number of tokens that we want to mint, and minting means these will be minted on the first instance when the ledger canister is installed, and also we have to set up the transfer key, an amount that will be charged by to the for the user every time they do a transaction. And so here it is in this is 10,000, but the token standard token base mode on ICP is 8, and so 10,000 divided by 8 is get around 0.0001, if I'm not mistaken. And so that's the fee that the user will have to pay every time they do a transaction using this data. So I also copy that and paste it here. I press enter. No error so far. Alright, so we are here on the next step, and here we're saying that DFX against a new archive controller. So we have to create a new identity called archive controller, and so what that means, about archive is usually the ledger canister has a determined storage capacity, let's say maybe 10 MB or whichever, but it is fine. And so meaning that Along the way, when users do more and more transactions, it reaches a point and the storage, gets done or gets occupied with transactions. At a point, it could run out of storage, and that would increase it needs to the developer or the one that deploys the token. And so what archiving means is that it lets you set a threshold, meaning that you set the kind of that whenever I reach 2000 transactions in my token ledger, I should save them somewhere and clear them from the ledger so as the token ledger can retain its space or it can regain its space. And in that way, it won't ever run out of space and maybe cause issues. And so this is how you set the archiving and everything that is going for archiving. And you can see the trigger threshold, the archive controller, the number of blocks to archive, cycles for archive creation, as you can see. And I will just copy everything as it is and press it here, press enter. The same identity already exists, meaning it's already created new archive controller identity. So you just skip this step, use do this, and then set the rest of the parameters down here. So let me clear my terminal. Alright, we are here now. And this export feature is flagged export equals to. Right now, the two, the ICRC1 standard and also the ICRC2 standard, and by default, token ledger only support ICRC1. And so, if you want to support the ICRC2 standard, you need to actually enable the feature plan to true, and that's what we are going to do. So, I will just copy this and yeah, just paste it to my terminal. And this will allow my token manager to support both the ICRC1 standard and also the ICRC2 standard. I'll just press enter and I'll be good to go. And so right here there is a simple, guide that explains everything that we've been doing, what all these variables mean, and that are actually in conjunction with the code. And alright, so we are now in step 7, and step 7 is actually to write the real command that will help us to deploy our token ledger. And I will just copy everything. First step is here, as you can see it, and as you can see, it calls the latest deploy method from SDK and calls the ledger, the name of the ledger that we want to install, or want to deploy, and this function actually specifies that we want to deploy our ledger with a specific ID, which is this. And then by default, if you don't include this uh, command or function command, is that the network will create a random ledger and you will receive a new identity or a new ID for your ledger. And so, but for our case, we want to deploy a specific ledger with a specific name, like ID. And so it takes in the variant and the argument, and as you can see, we're trying to define a different things, just like token symbol, token name, minter, token party, and we're also minting the initial balances. We want to give all our pre-minted tokens to the principal address that will save the null variable different. And the other thing is that we don't need to worry about it. So I will again copy this and paste everything down here. So let's hope our token ledger is created successfully. So I just press enter and you see that it's deploying the token ledger canister. Alright, and as you can see, it is done. So we've given us the URL, so open it in the browser. Alright, so Era and Abraham, it is okay. And therefore, you need to look back here. So I guess open it again and just get it and it opens up. Right, so as you can see, this is the interface that is defined in the ledger.bid file. And so all these functions can be called on your token canister. And that's how you create a token canister. And so we have a couple of different functions. We get growth, we get data certificate, we get transaction, and RC1 banner solve, and RC1 decimal, and RC1 fee, metadata, name, supported standard, RC1 symbol, total supply, and a bunch of other functions. And so it's time now to test out if actually we deployed our canister successfully. And the first thing that I would like to do is actually check the name, which is the test token, meaning and the same name that we defined. And if you check on the symbol, it should be double T, which is still true. And the supply should be that. I think this is from my previous uh, testing, but I can fix that. Alright, so if I run the previous command and then put node because we installed, then I do this. And this will reinstall everything so as we can have a brand new canister. I think I've already created it when I was testing stuff out, but it's okay. Now we will have a brand new canister created for us. Alright, so I just need to refresh this, and if I check the base model should be still okay, the RC1 name should still be okay, the symbol, but now the total supply should be 0, or rather, right, so not 0, but I think 10 million or 10 billion, and this is because uh, we preminted, we premined these tokens and we gave them to the principal address belonging to an agency using regular default. And so that is it about how you can configure a simple token ledger canister. And as you can see, we can tell some of these functions. Minting account already that, IRC metadata, and see decimal that by default it is 8. So now it's time we check out the balance, and let me first get my screen, NDFX identity, who am I, archive controller. So I get the principal address of this identity, and see that but then down there you see that it is ICP. And that is because the 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 population there is so and that allows us that that allows not that is a way that is called ICLC1 partner that is ICLC. So one partner is that the ICLC in that partner is that the all those and the ICLC and the meaning that you new high school student you can just find the app and you can visit and so that is really more than the way that now it's going to pick it up. So we have this local specific so let's do plasma and then see what is being laser and then so this is what is being and so let's go back to it and then using SPSC and laser and let's go to use it so let's go down to system and this is really like energy and possibility is this first this is here and the other point is that is doing this is kind of the goal is called the ICA and this and another thing is called the ICA and the and the people and the silver and also the amount that is and so I will just get the two things here and then I will and then I will do this here and I will call the rest of the book and then when you call this ICSA and after it knows that info and the for the distance then you now access and then it is info so you now access to the info and it will after it get less amount from this buyer. So if you are under the code it will give all about the distance and the info this amount from this balance and then the minimum you need to call this function is looking for how it is the code is written. And so I will just this is my keyboard the effects. Get principal again. If I copy this and go back to my ledger, if I try to check the balance again, it should have reduced by some amount. All right, so now we've seen that it has reduced by some amount. And so basically what is happening is that this amount reduced by exactly like 100k, and the 100k consists of the 90k that we sent to this user and also the 10k for the feed. So
whenever you do a transaction, you will, get charged a fee of around 10K. And that's not a big, a big amount, since it is, in decimals. If you get 10K divided by 10 power 8, you just get 0.0001, then maybe TT tokens. And so that's the fee that you pay every time you do a transaction. And so now that we've confirmed that the balance of this address reduced, can we check and see if the address of this increased? Yes. So copy it, come back here, paste it, and boom, you have your 90K tokens in here. So meaning our transfer is successful, and that is a cool way to demonstrate. And so now that we've made our first transaction, we can also get transactions, the transaction history that is stored in the ledger canister. And how we do that is, come to this get transactions function. We specify the starting index and also the number of transactions that we want to return starting from that index. So I will just put 1 and 1, and then I click OK. You will see that since we have only one transaction, it's the only one that is returned. And let me see if my OBS is still recording. It has a habit of stopping itself out, but it's still recording. All right, so this is how we get transactions on from the token ledger canister. You just specify the starting index and also the number of transactions that you want to return from that index. If the index, maybe you specify a lower index than like if there are any transactions from that index, then they will be returned. If not, we'll return an empty array or an empty object. And so we can do, we've checked out the decimals, we've checked out the fee, the metadata, the minting account, the name, and also the supported standards. We support, because of the feature flags, because of us enabling the feature flags, we support both ICRC1 and also ICRC2 standards. And so let's now, let me see. All right, so okay, so what we can do actually is we can do more transactions. And now I want to do some special transaction, meaning I will send tokens to the anonymous identity. But first I need to get its principal address, and then the FX identity get principal. So this is the principal address of the anonymous identity, and I want to replace it here, so as I can also receive some tokens. All right, so switching back, use default, then clear the screen, copy everything here, and paste it. So our identity should receive some tokens, and so the transaction is successful. So if we check the balance of this principal, it's very short, and that is, it was reserved majorly for the anonymous identity. So if we check the balance of this principal address, it should also have some tokens. Doom, it does have some tokens. And what I wanted to do with this is because right now, if we call any of these functions from the browser, since the browser there is no identity logged in, it calls our canister as an anonymous user, and the principal address is this. And what I wanted to do with this is now, try to use these methods right down here. So as you can see how everything works out. and I will come back to my terminal. Dfx identity, use test ID, then dfx identity get principal. So I want to approve my rather this principal address to spend tokens on my behalf or on behalf of the anonymous identity. So I will just come here, paste this, but actually we need to first check whether it has any balance, and I doubt it has. And so right here, paste query 0. It has 0 tokens. And so I'll just come here and all right, paste the address here, and then maybe I want it to do 5,000 tokens. I want it to be able to transfer 5,000 tokens on my behalf. So I'll just call and it is okay. And so these boxes, or rather these options where you see the different boxes, it means that these are optional. You can specify them or not. If you don't specify them, the canister has its default, has a way of handling all this inside its code. And so now that my anonymous principal has approved this principal to spend 5,000 tokens on its behalf, we can actually come and test it out. We want the spender and also the anonymous principal, which is right here, which is the owner. We see whether it's true that this guy was allowed to spend 5,000 tokens, and that is it. You will see that actually it's true. This principal is allowed to spend 5,000 tokens on behalf of the anonymous principal. And that's how, after approving, you could go ahead maybe in your code, if you're writing code, and then now call the ICRC to transfer from, and then specifying if you're, using that, if you're calling that function using the rather this ID, and then specifying the anonymous principal as the from, then you should be able to transfer. My apologies. You should be able to transfer tokens on the anonymous principal's behalf. And so that is it basically about everything you need to know about tokens. There are different standards actually of token ledgers. There is ICRC1 coupled with ICRC2. There is also EXT and also DEEP20. But for now, we are focusing on ICRC1 since it is like the standard. This standard was developed by the Definity Foundation themselves, and they want to make it the major standard. So the other phases, the other standards are kind of phasing out. And okay, so going on from here, so I want us to talk about this get transactions function. And so what this does is that it allows you to get transactions from the token canister. So it allows you to get the transaction history from the token canister. But we have one problem with this, in that you cannot get specific transactions tied to maybe a certain principal address. You only get transactions by supplying the index and also the number of transactions that you want to return. So this is not, a cool way to retrieve transactions, in that I would want maybe to get maybe the transaction history of a specific principal address, but there is no way how this allows you to do that. So that's why Definity introduced in another canister, and it's called the index canister. So what the index canister does is that all you need to do is link it to the token canister, and it will sort all the transactions and sort them by the different principal addresses. So in that case, you can just retrieve transactions tied to a specific address, instead of having to first retrieve all the transactions and then filtering through to get transactions for a specific principal address. And so we will move and actually install the index ledger, so as we can test out what I'm talking about. And so going back to the guide, you see that there's also this option of ICRC1 index local setup. And so they tell you what the ICRC1 ledger does and the guide. And so basically almost the same steps as when we were installing the token ledger canister. Create a new project, navigate to that project, fetch the thingy. Now we want to do this. We will just configure our dfx.json. And so in our dfx.json, we already have, or let me first delete this as the error goes away. In our dfx.json, we already have the ICRC1 ledger canister. So we just need to add on the ICRC1 index canister. All right, so just copy this, come down here, paste it, and all right, so where's the error? The error is here. I delete this, the error goes away. So I also need to replace this with the current replica version. Okay, the current replica version, and I save the changes. All right, so now we have defined that we want to install the ICRC1 index canister in our project. And so if you go back to the guide, you will see that we need to start the replica, which we've already done. And now we have to run this command. So copy it, come back to that, and then now we just paste it here for once, and then maybe we can check out what the command does. So it calls the defects deploy command. We want to deploy our ICRC1 index canister. We pass in one argument, which is it takes in the principal address of the ledger canister that we want to link it with. And I've already told you, this index canister links up with the token canister, and it fetches all the transactions and sorts them according to different principal addresses. And so we are specifying that we want to link our token canister, which is and this is its principal address. If you check it out, local, then canisters, you see that the ledger is actually here. And all right, so going back, we will just copy this, actually cut, paste it, and then I had already installed it some time ago, so I will just reinstall it again, so as we get a fresh and newly created index canister. Okay, and that is it. It's now installed, and if we can open it up in the browser. All right, first trial wrong, second trial should work. All right, so here it is. It doesn't have a lot of functions, and so it has this major function: get account transactions, get blocks, get fee collectors ranges, and ICRC1 balance of ledger ID, list sub accounts, and status. So clicking on status, number of blocks synced equals 4, meaning that when we specified the ledger canister, this canister connected to the ledger canister and then synced 4 blocks from that canister, and all those blocks include transactions. And ledger ID, that is the ID of the token ledger that this index canister is linked to. All right, so ICRC1 balance of we know, and get blocks I think also no. Maybe we can test it out 1. So blocks, you will see that it brings some weird information that is not human readable, but that's okay. So, but I'm interested in this function, get account transactions, in that it allows you to specify the total number of transactions that you want to return, and also which principal address that we can consider. So going back here, let's first fetch actually transactions for the anonymous principal. Where is it? 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 Right here. I copy it, go back here. I just maybe want to create return to, and then my anonymous principal, it's here. All right. So you will see that it has return to transactions. The first one, it shows actually, it even shows you the balance of the current principal address, and the first transaction was of type, where is it, type approve, when we were approving our principal address to spend 5,000 tokens on our behalf. And then the second transaction also, let me see, it's of type where is the type, I think transfer, kind actually transfer. And here we were receiving actually 9,000 tokens from our default principal address. And so as you can see that this method, we have been able to actually retrieve the transaction history for a specific principal address, instead of getting this. Let me copy this. All right, instead of trying to use the token ledger canister, which only allows you to retrieve all the transactions, and you have to filter them manually to get the transactions that you need. And so that's the major use of the index canister. All right, so that's the major use of the index canister. It allows you to sort transactions by account or by principal addresses. And so that is it major about tokens on the internet computer. And yeah, it has been an exciting session. I hope to stop from here. But now that we've configured our token ledger and also our index ledger canister, the next step is actually to start using these ledgers in our code. So in the next session tomorrow, we're going to talk about how you can use these ledgers inside your code, majorly in the back end. You can also talk about how you can use them on the front end using some cool libraries, but that is for the next session. And so thanks for the audience, and let's meet in the next session.